You're standing on the edge of a cliff in what is now the country of Indonesia, and the sky is turning the wrong color. Not the orange of a sunset, not the gray of a coming storm. Something darker, something total. The ground beneath your feet has been shaking for days. The animals went silent a week ago, and now the mountain across the water, a mountain so tall it scraped the clouds, is simply gone. In its place is a wall of ash and fire so enormous it blocks out the sun. You can feel the heat from 30 miles away. You are watching the end of your world, and you don't know yet that you may be one of only a few thousand human beings left alive on the entire planet. Here is the question that has haunted scientists for 30 years. Did a single volcano almost win? The story begins not in Indonesia, but in a genetics laboratory. In 1998, a population geneticist, a scientist who studies the history of human beings by reading their DNA, named Stanley Ambrose at the University of Illinois, published a theory that stopped the scientific world cold. He was looking at something called genetic diversity. That means the total range of differences between people's DNA. Here is why it matters. The more people there are in a population over thousands of years, the more variety you see in their genes. But if a population crashes, if most people die at once, that variety narrows dramatically. It's like shuffling a full deck of cards versus shuffling just 5 cards. You get far fewer combinations. What Ambrose found was that human beings, all 8 billion of us alive today, have shockingly little genetic diversity compared to other species. A single troop of wild chimpanzees in Africa has more genetic variety than the entire human race combined. This means something devastating must have happened. At some point in our past, our ancestors were reduced to a tiny group, possibly just a few thousand individuals, and every human alive today is descended from those survivors. Scientists call this a population bottleneck. Imagine a river that suddenly narrows to the width of a single door. Everything that passes through that door is all that's left. Whatever doesn't fit through simply does not continue downstream. That is what happened to us as a species. Almost everything was lost, and only a thin trickle of people made it to the other side. The question was, what caused it, and when did it happen? The answer was already waiting in the geological record. In the island of Sumatra, Indonesia, there is a lake called Lake Toba. It is enormous, roughly 60 miles long and 18 miles wide. It looks peaceful today. Tourists visit it. But Lake Toba is not a lake in the ordinary sense. It is a caldera. A caldera is the collapsed crater left behind after a supervolcano explodes from the inside out. Approximately 74,000 years ago, the volcano beneath what is now Lake Toba erupted. Scientists who study ancient eruptions, called volcanologists, rank this event as the largest volcanic eruption in the last 2 million years. It ejected somewhere between 2,500 and 3,000 cubic kilometers of material into the atmosphere. To put that in perspective, the famous 1,980 eruption of Mount Street, Helens in Washington state, released about 1 cubic kilometer. Toba released 3,000 times more than that. The ashfall alone covered the entire Indian subcontinent. Researchers have found layers of Toba ash in India, in the bottom of the Indian Ocean, in East Africa, and as far away as Greenland. This ash layer has a technical name, the youngest Toba tuff. Tuff simply means hardened volcanic ash. When geologists drill deep into the earth and find this layer, they know exactly what they're looking at and exactly when it was deposited. Picture what that ashfall actually meant for someone standing in India at the time. The sky would have turned gray, then white, then nothing at all. Ash would have fallen for days, maybe weeks, coating rivers, choking lungs, killing the plants that animals needed to survive. In some places, the ash piled up several inches deep, turning green land into something closer to a frozen desert made of dust. But here's where it gets unsettling. The ash was only the beginning. When Toba erupted, it pumped enormous quantities of sulfur dioxide into the stratosphere, the upper layer of Earth's atmosphere. That sulfur dioxide mixed with water vapor and formed a reflective layer that bounced sunlight back into space before it could warm the Earth. Scientists believe this caused what is called a volcanic winter. The planet cooled rapidly, possibly by 3 to 5 degrees Celsius on average, though some studies suggest even more in certain regions. 3 to 5 degrees doesn't sound like much, but it is catastrophic. That level of cooling, sustained over years, could kill forests, freeze crops that didn't exist yet, and wipe out entire animal populations that early humans depended on for food. The volcanic winter, researchers believe, may have lasted between 6 and 10 years. A decade of cold, darkened skies, dying plants, and starving animals. Then, following the winter, a much longer period of global cooling may have continued for up to 1,000 years. Archaeological evidence seems to confirm the devastation. In India, researchers led by Michael Petraglia of the University of Oxford found layers of stone tools both below and above the Toba ash layer. This is a genuine and actively debated finding. Below the ash, tools. Then ash. Then, for a long period above the ash in many sites, nothing. The record of human habitation simply stops. When humans reappear in the archaeological record in some regions, they are using slightly different tools, suggesting the populations that returned may have come from somewhere else, or were so reduced that cultural knowledge was lost and had to be rebuilt. So who survived, and how? This is where the science becomes genuinely extraordinary. A study published in 2010 by researchers including Lynn Jord at the University of Utah analyzed human mitochondrial DNA, the genetic material passed down through mothers. Their analysis suggested the human population may have fallen to somewhere between 3,000 and 10,000 breeding individuals. Some estimates go even lower. A 2000 study by researchers Ambrose and others suggested the number of humans capable of having children may have dropped as low as 40 breeding pairs in some populations. The survivors, most researchers believe, were likely small groups living in coastal or sheltered environments. Some evidence points to southern Africa, where caves and coastlines may have offered more stable food sources even during the volcanic winter. Shellfish, ocean fish, and coastal plants may have kept small groups alive when inland ecosystems collapsed completely. Think about what that means. While the inland world was dying, a few small groups along the coast were quietly surviving on shellfish and fish, probably never knowing how close the entire species came to disappearing. They were not heroes. They had no idea what they were part of. They were just hungry people near the sea, doing what hungry people do. But here's where it gets unsettling in a different way. The Toba catastrophe theory, that's the actual scientific name for this hypothesis, is not universally accepted. Some archaeologists, including those who study sites in South India more closely after 2007, found evidence that human populations in certain locations survived the eruption with surprising continuity. In other words, some groups may not have been wiped out at all. The debate is real, ongoing, and genuinely unresolved. Science works this way. The theory is serious and supported by significant evidence, but is still a theory, not an established fact. What is not debated is this: the genetic bottleneck happened. Something nearly erased us. Whether Toba was the sole cause, a major contributing cause, or one factor among many, is what researchers continue to argue about today. What makes the Toba event so haunting is not just the numbers. It is the silence it leaves behind in the human story. For tens of thousands of years before 74,000 years ago, early humans were spreading, making tools, painting caves, crossing into new territories. Then, the record grows thin and quiet. And when it returns with full force when humans begin their great expansion across the globe, that eventually reaches every continent, there are signs in the DNA that they all came from a remarkably small common source. We are, all of us, the children of survivors. Every person who has ever lived in the last 70,000 years descended from a group so small you could fit them inside a single modern sports stadium. Here is what most videos about Toba do not say out loud, and it is the most important part. We treat human civilization as if it is permanent. We talk about history as if the story of humanity was always going to continue, as if our presence on this planet was guaranteed from the beginning. Toba tells us something deeply different. It tells us that the human story very nearly did not continue at all. That 74,000 years ago, through no fault of their own, our ancestors were reduced to remnants so small that their survival was closer to luck than certainty. The people who survived Toba did not know they were saving the future. They were simply trying to eat, trying to stay warm, trying to find one more day. And because they did, because enough of them held on through years of cold and darkness and starvation, you exist. This conversation is happening. Every book ever written, every city ever built, every song ever sung exists because a few thousand frightened people in coastal caves did not give up. There is something almost unbearable about how thin that thread really was. A slightly colder winter, a slightly worse harvest of shellfish, a handful of fewer births in a single generation. Any of these small things could have ended the entire human story before it truly began. No one alive today had any say in it. We simply inherited the outcome of strangers fighting to survive a sky that had turned against them. But the implication goes further. The same geological forces that created Toba are still active. Yellowstone, in the United States, is a supervolcano. So is the Campi Flegrei system beneath Naples, Italy. Researchers, including those at the British Geological Survey, continue to monitor these systems, not because eruption is imminent, but because we now understand what supervolcanoes can do to a species that believes itself secure. We are not living in a stable world. We are living in a quiet moment between events. The volcano did not nearly win because it was powerful. It nearly won because we were unprepared, scattered, and small. The question Toba leaves us with is not just about the past, it is about right now. Are we paying attention this time?